And Christian?
Okay, I'm not muted anymore. Does that work?
Yes, it looks good. Thank you.
Okay, let me go into presentation mode. Okay, thanks for the opportunity to speak here. I'm gonna give a talk focused more on, our efforts to build an open source community around Kokkos and how that, how that is going and how we are going about that and what are the kind of, challenges, etc. So I'm not going to give you much in terms of introduction of what Kokkos does or how it works and stuff like that. But there's tons of material. If you don't know that yet, you can look at in the web. So basically, just as a short thing, Kokkos is there to isolate you from, all of you and all the apps and whatever from all the underlying, problems going on in the hardware and the different machines we are buying, from all the diversity we are getting in all these machines. And so the idea is that instead of trying to deal with all the different programming models people are trying to push on us, you write your code in Kokkos and then Kokkos deals with all the underlying issues underneath it. Yeah. So, and basically, oh my goodness, this doesn't work. Let me, just 1 second. I'm gonna delete this. Screw it up. So basically, we are now at a point where, I think we had kind of quite substantial success. Whereas it's actually relatively hard to measure that at this point. Like it's kind of hard for us to figure out who's actually all using Kokkos. We lost a bit of, we kind of lost track of that largely. But there are two things, which I think give, reasonably objective numbers, as in, at least it's an indicator in what direction it's going. One of them is in the ECP critical dependency list, right? And if you look in there, Kokkos has 18 critical dependencies, as in, other people depending on Kokkos. And the only stuff which is kind of above that, is like things like BLAS and, Fortran slightly, like 5 days ago or so, it actually was still under Kokkos for some reason, but apparently somebody woke up and said, yeah, we actually depend on Fortran. Maybe because I had made that point a couple times now. But it's like things like MPI, C++, OpenMP, LAPACK, BLAS, right? And then there's Kokkos. And if you look at the dependency for C++, right, it looks like, almost half of the codes in ECP which use C++ are apparently depending critically on Kokkos. So that seems to be, a reasonable uptake. And the other indicator we have is actually from our Slack channel. So our Slack channel is kind of our main communication channel right now we have with people. And we have about 460, a bit more than 460 registered users right now. They come from something like 70 different institutions. They come from every continent. I'm not sure if anybody is there from Antarctica because it's hard to, get domains associated with that. And it's been doubling about every year now. One interesting fact about that is if you look at how they are distributed, right? About 20% are from Sandia, where Kokkos started, right? A bit more than half of them are DOE, and another 20% is universities, and then the rest, about a quarter is other people, right? People from actual like industry companies, right? As well as other like government agencies like NASA and DOD, etc. So the interesting question is, how did we get there, right? How did we get to that point of growth, and what did we do in order to get there, right? What does it take to get there? And I think the first critical point about it is you really have to start with a problem, like an actual problem for people, which is so heart-burning that they might be interested to do something about it. And the fundamental problem at the core of all of this, what Kokkos is trying to address is the cost of porting code, right? If you look at industry estimates of how much can a full-time like software developer do, right? You can write about 10 productive lines of code per hour. So maybe 20,000 lines a year. And you know, that is if you don't do anything else, right? You don't write any papers, you don't like, you know, try to apply for funding or whatever. It's all about, you know, people like at Google, you know, who are software engineers and don't do anything else than doing software engineering. And if you look at, you know, what it costs you to jump from one model to another, right? A very optimistic estimate is that you have to touch about 10% of your code from our experience right now, right? And if you look at like typical applications, you know, at Sandia, most of those are somewhere between 300,000 and 600,000 lines. I looked at, you know, a couple dozen codes there. You know, that's about 2.5 developer years to, you know, move, say, from, I don't know, something like OpenMP to CUDA or something like that. In large scientific libraries, you know, that's way more than that, right? Because it's millions of lines of code, and so it's significantly more than that. And this is, you know, moving from one parallel programming model to another. It's not actually about, you know, make your code work on GPUs the first time around, because that's significantly more effort. So there's this timeline for Kokkos, right? And I'll go in some of these aspects in a little bit more detail in just a minute. So we started actually quite a while ago, right? That we started Kokkos kind of in 2008. And the initial Kokkos was more focused on linear algebra for Trilinos. You know, and I'll get into that a bit. I remember it was this restart, you know, and we did a lot of like internal stuff at Sandia, and the actual first like public release on GitHub, you know, as a standalone product was in 2015. That was really when we started, you know, engaging more external people. So that's about 7 years later, right? And you know, now we are like, I don't know, another 5 years later, where we actually start to have like really significant uptake, you know, outside. So the early developments, as I said, it started kind of in 2008, right? And that first phase was like 2008 to 2012, what we call now Kokkos 1.0. It was mostly developed for portable linear algebra, so it wasn't like used widely. It was mostly just used, you know, at that lowest point in the stack, you know, for implementing portable linear algebra, you know, targeted at things like Titan. It didn't have multidimensional views yet. You know, it didn't have the concept really of like memory spaces and all this other stuff, you know, in that kind of detail. And then there was this LDRD project by Carter Edwards, you know, called Kokkos Arrays at the time. And what that was doing is it was trying to expand Kokkos 1.0 with layouts. Essentially, the problem recognized at the point was that there's this layout problem, that you need different data layouts on GPUs and CPUs, and also that you have to kind of bind that together with the dispatching, right? So your scheduling of tasks need to be kind of, or iterations need to be, you know, matching what you do with like layouts. And a simple example for that is, you know, I'm doing here a matrix, dense matrix vector multiply. And in principle, you would expect that as, you know, essentially bandwidth limited, right? And if you do layout left versus layout right, which is, you know, column major versus row major, and measure it as against, you know, the percentage of stream bandwidth, it turns out that, you know, it's actually kind of funny. I did that on a Skylake with a Volta. And it's exactly reverse images, right? You get about like 15–16% performance with the wrong layout on CUDA and OpenMP respectively, and about, you know, like 85% with the right layout. The problem is it's the different layout on each of these platforms, right? As on the CPU versus on the GPU. And so this was designed to resolve that problem. What then really started and was a big part of building trust, at least with, in particular within Sandia, was we did these initial demonstrations, right? So we demonstrated feasibility of performance portability through like mini apps. And at the time, right, we actually wrote, this was part of this Mentivo suite, right, where we developed all these mini apps, and we developed them and we wrote them in actually a lot of different programming models. We didn't even make all of them public at the end. So some codes like mini-FE had like, I don't know, 16, 20 different versions in like 8 different programming models. You know, some of them a bit obscure, and we actually never made them public. And one of them was Kokkos, right? And what we tried to do, demonstrate where that this actually works and that we can get that performance. We even went it in part of a DOE Trilab collaboration, a co-design effort, right? We actually took somebody else's mini apps, you know, in this case, Lulesh, to demonstrate, yeah, this isn't designed for how we write code at Sandia, right? It generally works. And we did all these kind of, you know, studies. This data here is super historic data, right? So this is what we had at the time. All of this data is, you know, completely obsolete, right? As of this doesn't mean anything today. And what that helped us do is it started with internal growth within Sandia, right? That is this kind of period going up to like 2015, 16, 17. And one really critical point there was that it wasn't us really convincing in the beginning, right? Apps to, oh, here, try Kokkos out and put that in your apps. It was rather the other way around, right? Kokkos developers put Kokkos into mini apps, LAMMPS and Trilinos and stuff like that, right? With Kokkos developers, actually, that was largely me. We weren't that many people at the time. And it was pretty critical, you know, that we did that and that we had somebody like me on the team, you know, who actually also was a developer of LAMMPS and Trilinos at the time. And demonstrating that this worked, right, in LAMMPS and Trilinos, you know, and that it was competitive with what was done before there, with like raw CUDA and stuff like that, that was absolutely critical to convince more internal teams to try this out, right? And for many of these apps, in particular for our real production apps, right, they started toying around with Kokkos, you know, in like 2014, 2015 kind of. But to actually have real uptake and first like, and really commit to it, right, took years, really. And it took a lot of patience and a lot of like convincing and demonstrating and stuff like that to make that work. Part of the problem is that our app teams are largely not in the same center, you know, as the Kokkos team at Sandia. The Kokkos team is in the computer science center, while the app teams are more in the kind of engineering and computational engineering kind of areas. So, you know, it's not that we were all like, you know, as the collaborations back in the day weren't as tight as one might would have hoped. And it got much, much better in the last few years. What was then a real big help was that we had this ATD-AMP initiative. And that was a program level initiative where after all this initial convincing was, you know, and enough people were convinced, right? The program level effort actually said, okay, yeah, what we're gonna do is we're gonna do software modernization and we're gonna use these reusable components and we don't want everybody to develop their own solution. And that means, you know, that we base that on things like Kokkos, right? And having that kind of higher up, you know, push helped accelerate this quite a bit, right? Yeah, and then in 2015, which was, you know, kind of overlapping with some of that stuff, we released this Kokkos 2.0 on GitHub, you know, independent of Trilinos, because there's a lot of people who use Kokkos without needing like large linear solvers and all kinds of other pieces which are part of Trilinos, right? Like for example, LAMMPS, right? Doesn't need any of that really. They only want the programming model. A big part in that was training and support. So you can't just have a good software product, right? You also need to train people in using it and showing best practices and stuff like that. One really kind of clever thing we did there, and which in hindsight was, you know, really good that we did it, was we actually contracted a university for developing training material. And that kind of happened in 2014, 2015, and they developed on the order of like 100 slides or something, which basically gives you, including the hand-on exercises associated with it, like a full day kind of training, right? And that was, as it wasn't just that we handed that off to them, right? It was a really tight collaboration with those guys, in particular Jeff Amelang, who actually is now at Google. And you know, that was really important. We executed then like full day trainings at Sandia. We also had like collaborators from LANL coming in, you know, which helped quite a bit. One aside on that, our training is now significantly larger. We actually just executed the Kokkos Lectures, you know, which was part of, I'm coming to that in a bit, funding we got from ECP later. That is now 8 lectures, which, you know, 8 about 2 hours lectures each, covering most aspects of Kokkos. You know, it's like 15 hours of recording, something like that, 14.5 or so. About 600 slides total. You know, there's tons of like exercises with it. And all of these guys are online available now as recordings, right? And it really covers everything from a programming model, you know, like just the basic stuff, data management, etc., over things like nested parallelism, you know, scratch pads, how do you use like special hardware capabilities like shared memory. We're talking about like streams and tasking and SIMD integration. We talk about language interoperability with things like Fortran, Python, and MPI and like PGAS models. We have this whole thing about like profiling, tuning, debugging, static analysis, etc. You know, we'll talk about Kokkos kernels, the MARF libraries, etc. And I think that was actually a really cool project. Even though for 2 months I felt like the only thing in life I do is Slack and LaTeX. What then started is this external growth period, right? And that was in particular like, you know, the initial growth kind of 2015 to 2018. What we did there is we worked with some, you know, select external partners largely and collaborated with them more tightly. One of them, Uinta from University of Utah, right? They have this task model and they integrated Kokkos as the portability layer. And they actually had GPU capabilities before, but they showed that, you know, switching to Kokkos in the end actually gave them better performance than before, both on GPUs and on CPUs, because our programming model restricted them from doing some things which they probably shouldn't have done in the first place. We also collaborated with LANL quite a bit, which led to, you know, Kokkos becoming part of their ATDM effort. You know, that was really helpful to have a first couple of like focused external partners. And then we just started going around, right, providing tutorials and talks and stuff like that, right, at all these conferences and GPU hackathons and DOE meetings and stuff like that. We effectively, you know, for everything which kind of turned up, we kind of volunteered and, you know, kind of lived on the road a bit. And then what really helped was we convinced ECP to provide resources for Kokkos training. And one really clever thing we did there, I think, I always thought it was clever, is we didn't actually ask largely for money for us, but we largely asked for money for partners at Oak Ridge and LANL. And so, you know, we gave them most of that extra funding. And early on, most of the contributions were really limited to just organizing events and stuff like that, right? So the first couple of years in terms of like synergetic, you know, useful contributions to us as, you know, like the core Kokkos team was rather limited, right? But what it did is it lay a foundation, right? And that foundation really blossomed over the last like 2 years or so. And so it was super, super critical. I mean, we still got, you know, like all this organization with like the training out of them, you know, before, but it morphed lately into something much more than that. And one of the reasons that we did that, right, is that the biggest concerns for external user, right, was always, do we trust Sandia to be really committed to that and support us, you know, long term? And so building this kind of external, you know, making the team larger than just Sandia people was really critical. And what then happened is that we started, you know, in some sense it's branding, in some sense it's really the foundation of this whole ecosystem or with this whole community, is we started creating this Kokkos ecosystem, right? Where we don't just have the programming model, but we also have other projects, you know, which are in some sense stand alone, on their own, right? Their own entities, but we are tightly all integrated, right? We are talking to each other like all the time and stuff like that. And so one of the first things for that, right, was Kokkos kernels, which was just like the math libraries, right? The linear algebra, graph kernels, etc. Then through this ECP funding, right, we got this Kokkos support going with like documentation, tutorials, boot camps, and stuff like that. And then the other stuff we started was tools. So like debugging and profiling tools and tuning tools, right? And if you look at that, that kind of gives you all the kind of basic capabilities, you need to actually do real application development, right? It's not just the programming model, right? It's also the blast kernels you need to call. It's the tools you need to understand what's going on in your code. It's the training you need to, get up to speed, etc. And lately we've been branching out in some other areas, where we need to have tighter integration. One of them is with Kokkos remote spaces. It's things like PGAS, model integration, etc. Another one is interoperation with like Fortran and Python, which has become, asked for quite a bit. So we have solutions for that now. Another one, which is reasonably new and not released yet, is a resilience effort, which actually runs more or less on its own and just needs a bit of like integration with like the core thing, but which gives you things like checkpointing and redundant execution, etc. And all of that, is essentially helping us doing this transition to the community project. In particular, in FY20, we got quite a bit more money via ECP. And now Kokkos Core, right, the programming model, it has about 15 developers, and only about half of them are actually at Sandia, and the rest is at other labs, in particular Oak Ridge, Argonne, Los Alamos, and Berkeley. We actually have now more code contributions from outside Sandia than from within Sandia. And the kind of separation we have there is that Sandia still leads most of the kind of API design aspects, while the other labs lead largely the backend implementations at their facilities. So summarizing some of these key aspects, right? It was really critical that what we did is, right, was solving a problem where the status quo was not tenable, right? Essentially, a good chunk of our customers are just desperate, right, to find a solution to their problem of how do I deal with the fact, that there are GPUs in our lives now? How do I deal with the fact that after almost 10 years of NVIDIA being the only GPUs I had to worry about, none of the exascale machines really use NVIDIA, they use AMD and Intel stuff, right? That was really important, right? Solving a critical problem. A next aspect was, as I said earlier, right? You have to demonstrate that it works, and not just in mini apps, right? Showing some mini apps is fine, but convincing something like our engineering suites that this works, you don't do that with mini apps, right? You have to prove that in something bigger. And the problem is that the app teams don't really have time to chase after something they don't know or are reasonably confident that it works, right? So that means for a few real problems, right, you have to demonstrate that it works. And that can happen with tight collaboration with some kind of a willing guinea pig or something like that. But you have to invest the resources on your side to demonstrate this really, really works, right? Critical was also providing training and support. Without explicit money for that, it's really hard to get uptake. And then I think it was also really critical to expand the team, right? Finding more stakeholders and actually making them real partners, right? Not just like, farming out a little bit of work here and there, but actually make them real partners in the project, right? Actually put the project on a stronger, more widely distributed footing. That is, I think, absolutely critical, right? And part of it is that, we as the lead for Kokkos, right, we asked funding agency for money, but we largely asked them, for extra money of, like ECP, for other labs, right? The vast majority of all the funding from ECP, also from the non-NNSA side, for Kokkos goes to outside of Sandia, right? And so I think that was kind of critical. The big thing is every one of these steps takes time and patience, right? This is not a thing, you get done within a year or two, right? It really takes time. So there's a few challenges ahead, right? One question is, where do we go with our funding of development and maintenance work long-term, right? Right now we have this umbrella thing, with ECP, which kind of covers all of us, right? In some sense. I mean, even the NNSA ATM is to some degree under that umbrella. But where do we go, when that ends, right? We need to convince both, the ASC program and the OSCAR side, to fund this, right? We have to get multiple funding agencies to have, to agree to have skin in the game, right? And the question is, how do we encourage that, right? How do we make that possible, right? What kind of structure do we need in order to make that work, right? There is another problem we recently found, right, is that community tools, or tools to build communities and keep the community alive are absolutely critical for our effort, right? Like, for example, Slack has been super useful in scaling support, right? Without Slack, I think a lot of this, in some sense, some of this wouldn't really be possible, right? And we're running on a free version right now, but on the free version, you have like 10,000 messages history. And considering that we have over 500 messages a day now, we are at less than 20 days of history, right? But the question is, can we get funding for this, right, to switch to the paid version? My estimate is that if we have like about 1,000 active users, which is, like the current growth curve, we reach that in about, 2 years. We estimate that we need about 100K a year to support that. On the other hand, 100K, it's less than a postdoc, right? And if you ask me, do I want, fully functioning Slack or an extra postdoc? I would tell you I would want, fully functioning Slack. And considering the overall budgets involved, 100K isn't like huge amount. It's just something, we are not used to spend for this kind of services, in these kind of projects. And then there's a question, how do we expand support to commercial customers, right? DOE is funding us to support, users of DOE platforms right now. But, we had interest from even some really big companies in potentially using Kokkos, right? And their efforts would be on the same scale as, what we do at Sandia in terms of our engineering applications, right? And what I'm telling them is, we can't really give you the kind of support you probably would need, right? That is not part of our funding profile. So the question is, how do we get there, right? Private-public partnerships, right? Maybe these big companies themselves need to become part of the Kokkos Core team, right? And have like one guy be the developer of Kokkos Core full-time, right? Maybe there's an opportunity to engage, commercial support via contractors or something like that, where other companies pay some, central contractor who does work with them, and they work with us on the project itself, right? So these are questions I think we need to resolve and answer in the, not too distant future. And we're working on that, but I think we don't have a really good answer yet to any of those. Okay, and with that, I'm at the end of my talk and can potentially answer some questions if there are questions.
There is a question from Todd.
It's not really a question. It's just a endorsement of Slack. In that, like, that's been tremendously helpful for us in growing the community, because the support just, people handle the support. So, I mean, we have like 70 users actually posting things per day out of like 800 plus total on Slack. And oftentimes they answer the questions for us before we get a chance to answer them.
Yeah, that's something we start to see as well, right? That other people, as non-Kokkos people, answer Kokkos questions, right?
Yeah.
And I think that is the way of how, you can scale out, to a larger community, having the community actually help with support. Yeah.
Yeah, and I mean, also documentation is critical. I think that's probably the thing that most projects overlook.
Yeah.
And it's unfortunate because I think it's also the thing that gets you the most users. Like if people can't find documentation on their project, they just move on really quickly because I don't think they don't think they're going to be able to figure it out.
Yeah.
So like it really is worth like sitting down for the week or a month or so that it takes to bang out like high level user and developer docs for things.
Yeah. At some point, you know, in some places where I'm like wondering, you know, would it be possible to have like, you know, technical writers or something like that, you know, who are shared across multiple projects, right? But, you know, whose main task it is to do this kind of stuff, right? I don't really need, you know, a PhD level, you know, senior or principal member of technical staff, you know, sitting there writing websites and wikis, right? That seems a bit of a waste, right, of stuff. But you know, that's all we have.
Yeah, I guess I think that to write good documentation, you have to understand the conceptual aspects of your software. So like, I mean, I don't think you can I don't think it's very good to offload documentation to like new people who have no experience using the thing either. So like, there's a happy middle ground there somewhere.
Well, thank you very much, Christian. We will resume at 12:30 p.m. Pacific time in an hour and learn more about MVAP-H2. And please join us in the afternoon. Thank you.